In this video, we are going to be discussing linear functions. The objective of our lesson today will be to identify a function by its graph and table, and also to be able to find the range of a function with a certain given domain. Here I have examples of graphs. In the left column, you will see graphs that are functions, and in the right-hand column, you will see graphs that are not functions. Take a moment and look at these two sections of graphs and see if you can figure out why the left column is a function and why the right column are not functions. You will notice that the functions, the graphs on the left, are different from the graphs on the right. Because if you were to draw a vertical line anywhere on the graphs on the left, that vertical line would pass through only one point on the graph. Let me give you an example. I've drawn a blue vertical line on this graph, and notice that when I have this vertical line, it passes through only one point on this graph, which looks like a V. And I actually can take that vertical line and put it anywhere on this graph, and it is only going to pass through one point. If I slide it, it still goes through one point. In the second graph, the same thing happens. I take that blue vertical line and I can pass it along this graph anywhere, and at only one point will that vertical line go through this graph. Let's take a look at the third one. Same thing happens. I can slide this vertical line and it's only going to pass through one point on these graphs. The difference being, if I slide this vertical line over here to these graphs, notice that that vertical line passes through two places on this particular graph. Or if I bring the vertical line down to this graph, you'll notice that this one passed through 2 points. Or if I bring the vertical line down to this graph, you'll notice that the vertical line passes through 2 points. So what we're working on is something called the vertical line test. If a function passes the vertical line test when a vertical line passes through only one point on the graph, then we know it is a function. Now let's take a look at functions where we also see their tables. Now if we take a look at the first function where we have the shape of the V, if we were to put several points into this XY table, what we would see is these ordered pairs would show that they are a function. For example, in this one we have the point 0, 2, and we have the point 1, 1, and we have the point 2, 0, and we have the point 3, 1, to name a few. If we take a look at this function, it appears that we have the point 1, 2, and if we follow that function up, we would have the point 1, 2, 3, 4, 3, and so on, and there would also be some with fractions. Now if we go over to this particular function that looks like an oval, if we put in a couple of points, we'd have the point -2, +1, and then the point -2, -1. Now notice that we have two x values. These are exactly the same x value, but the output, or the y value, is two different y values. So for one x, we had two different y's. How about down in this graph? Let's put a couple of points in the table. Let's put these two that stacked on top of one another. So we had 0, -1, and we had 0, -2 at that particular place where they were stacked. And again, notice that the x value is exactly the same, but the y values are different. So we had one input for two outputs. So what we want to notice about a table is that for every input, there is exactly one output. We cannot have one x value have two y values and it be a function. So, what is a function? A function is when every input x, there is only one input y. Let's think about a vending machine. There are many appliances or machines in our daily life that operate as functions. And when the vending machine is operating correctly as a function, you put in your money, one input, and you get one item out, which is your output. To the person who's running the vending machine, or who gets the profits or stocks the vending machine, the machine is not functioning properly if you put in one amount of money and you get two items out. As the consumer, you might think that's a good deal, but truly the machine is not functioning correctly if you put in one amount of money for an item and you get two items out. Then we know it is not functioning properly. Same thing when we are doing a linear function. We put one x value in and we will get one y value out. It is not a function if we put in one x value and two y values are our answer. When we are using functions, we use a special notation called function notation. We use f of x, g of x, h of x, and so on when we know an equation is a function. For example, f of x equals 2x plus 7, and it is simply a different way of writing y equals 2x plus 7. But the y is a function of x. In other words, whatever we get as an answer for y depended on what we used as x in the first place. The x in f of x in the input value. So if f of 2, that means we are inputting 2 in for the x value to get our answer, our output. As a definition, the domain is all the possible inputs of a function, and the range is all the possible output of a function. Domain and range. Domain is the x values, the input. Range is the y values, the output. So let's do an example problem. It says give the range with the given domain. So my f of x is 3x plus 1. Really, the easiest way to do a problem like this is to simply make a t-chart or a table. So we are going to make a table, and our domain is our x values, our 0, 4, and our 5. We're looking for the f of x, which is the output. So what we'll do is we'll take the 0 and we'll substitute that in. So 3 times 0 is 0, plus 1 would equal 1, and that is my domain or my output. Then I'm going to input my next element of my domain, and I will put in a 4. 3 times 4 is 12, plus 1 would give me 13. And then I'll do my 5. 3 times 5 is 15, plus 1 would be 16. That's how we calculate the the range when we're given a specific domain. We input into the equation, do the mathematics, and the range is our output. Let's try another one. So we'll make our table. Our domain is our x values. We're going to use -2, +4, and positive 10. We want to find the range, which is our output or our y values. So we're going to take our function and we're going to substitute the negative 2 for the x and subtract 4. When we take negative 2 minus 4, that gives me negative 6. And when I multiply that by 5, I get negative 30. And negative 30 plus 1 is negative 29. When I use the 4 as my domain, my input, I'm going to put 4 for the x value, subtract 4, and then add 1. 4 minus 4 is 0. 5 times 0 is 0. And when I add 1, I get 1. In my last example, I'm going to substitute 10 for my x value, and I'm going to subtract 4 and then add 1. In parentheses, 10 minus 4 would be 6. 5 times 6 is 30, plus 1 would be 31. Let's review. When you have a table of values, remember that the x values have only one unique y value as the output if our table is to be a function. In a graph, functions need to pass the vertical line test, and please remember that your domain is your input and your range is your output. Please complete the reflection.